Hello coders, I welcome you all. In this video, we are going to build and implement MCP using n8n. But before we directly start building it practically, let's first understand a few very important concepts like what is MCP, why MCP is needed, what are tools, how AI agents use these tools, difference between systems with MCP and without MCP, how MCP manages these tools, MCP architecture and how MCP works internally. Because once these concepts become clear, implementing MCP inside n8n becomes much easier and much more interesting to understand. So let's understand this with a simple real-world example. Suppose there is a senior employee in a company. This employee is very intelligent. He understands instructions, can analyze problems, and can make decisions. But even after having all this intelligence without access to company systems and tools, he still cannot actually perform work, right? For example, if you ask him, check today's sales report, he needs to access to database, Excel sheets, and internal softwares. Or if you say, send meeting emails and schedule a call, he needs to access to email systems, calendar applications, and company tools, right? So even though the employee is intelligent, without tools, he can mostly only talk. He cannot actually perform actions. Same as earlier AI systems. So earlier AI models mostly generate answers, means only can talk. You ask a question, the AI responds. And that was pretty much the entire interaction. Means these interactions are limited to text generation only. Employee without tools that only can talk can't perform actions. But modern AI systems are changing rapidly. Today AI agents can use tools, access APIs, read files, search databases, work with applications, and perform actions automatically. And this is where agentic AI becomes really powerful, because now AI is not just generating text. AI can actually interact with systems and perform the task. Before we start discussing what is MCP, let's first understand what are tools. So tools are functionalities that AI agents can use to perform tasks. There are many such ready-made tools are available. We can also create our own custom tools. So here you can see list of already created tools, ready-made tools like calculator tool, Wikipedia tool, Google Drive tool, database tool, and API tool. There are many such ready-made tools are available. So instead of only generating text, AI agents can now perform real-world actions using these tools. And this is where modern AI systems become truly powerful, because now AI is not limited to conversation only, not limited to talk only. AI can interact with external systems and actually perform tasks. So now let's discuss what problems started after tools were introduced. Initially, connecting a few tools was easy. But as AI systems became larger and more advanced, things slowly started becoming complicated. Because now multiple agents needs the same tools, multiple workflows needed the same integrations, and different applications needed access to the same resources. Then what will happen? That's why gradually everything became difficult to manage, because every tool had different integrations, different connection methods, and different configurations. Now let's imagine we want to build systems with 10 different AI agents, and every agent needs same tools, same APIs, and same resources again and again. So without standardization, we repeatedly reconnect tools, rewrite integrations, and reconfigure setups, and very quickly managing everything becomes messy, that you can see here. So without MCP, the architecture usually looks like this, that you can see one agent connected with many tools. So AI agent has calculator tool, same AI agent has Wikipedia tool, same AI agent has Google Drive tool. For small systems, this setup works perfectly fine. But as systems grow larger, this approach becomes difficult to scale and maintain, because the tools are tightly connected to individual agents. This is exactly where MCP becomes important. So here you can see, let's start discussing MCP model Context Protocol. MCP was first introduced by Anthropic, and today it has become one of the most important concepts in modern agentic AI systems. In simple words, we can say MCP, Model Context Protocol, provides a standardized way for AI systems to connect with tools and external systems. This is why MCP is often called USB-C for AI applications. Just like USB-C standardized device connections, MCP standardizes AI to tool communication. So instead of directly attaching tools to every AI agent like this, MCP exposes tools through an MCP server. Then AI agents connect to those tools using an MCP client. Don't you worry, we will discuss entire architecture shortly. So here you can see system with MCP. So now the architecture becomes AI agent which is connected to MCP client connected with MCP server, and MCP server has many tools that you can see. And this changes everything because now multiple agents can reuse the same tools. Multiple applications can share integrations and tools become reusable and standardized. Means here tools are exposed through MCP servers only, that you can see here. Now let's discuss very important part, how MCP helps managing tools. And now this is one of the most important parts to understand. Once tools are introduced into AI systems, the AI model needs to understand which tools are available, what each tool does, when a tool should be used, what inputs the tool requires, and how responses should be handled. And managing all this manually becomes difficult as systems grow. This is where MCP helps. The MCP server exposes information about available tools. For example, tool name, tool description, capabilities, and required parameters. Then the MCP client communicates this information to the AI agent. Now the AI model can intelligently decide which tool should be used for a particular task. For example, here is the task. If user asks what is 1234 multiplied by 9876, the AI model understands this task requires the calculator tool. So now let's first discuss MCP communication flow. Then we will discuss MCP architecture. So here you can see step by step MCP communication flow. First, AI agent receives user question as we discussed like this. Assume that this is the question. MCP client connects to MCP server. MCP server exposes available tool information. Tool performs the task. Response comes back through MCP. And finally, AI generates the final answer for the user. AI means LLM, right? So please remember here the important part. MCP is not the tool itself. MCP is the bridge between AI and tools. Tools still perform the actual work. MCP just standardizes how they connect, right? So MCP is managing and standardizing how tools are exposed and used, not performing the task itself. To performing the task, still we require different tools. Please remember this, right? The tools still perform the actual work. Hope all of you are clear with this, right? If not, it will be clear shortly when we will discuss MCP architecture. And also at the end, we will take this complete example with help of MCP. Let's move on. Understand how MCP works. First, we have to discuss MCP architecture that you can see here. MCP mainly works using three important components that you can see here: MCP host, MCP client, and MCP server. So let's start with MCP host. The MCP host is the main AI application where the agent runs. And here you can see different examples of MCP host: Cloud Desktop, VS Code, AI applications, and it may be n8n workflows. So these are MCP host. Now let's discuss MCP client. The MCP client acts like a connector between the AI application, means MCP host, and the MCP server. Its responsibilities include sending requests, receiving responses, and handling communication properly. So we can say MCP client, which is the bridge between MCP host and MCP server. Now let's discuss MCP server. The MCP server exposes tools, resources, and prompts, right? So when a client connects, MCP server tells the client which tools are available, that we already discussed, right? Here, right? So as I said, when a client connects, the MCP server tells the client which tools are available. Then the AI agent can use those tools whenever required. So here you can see simple MCP flow. AI agent to MCP client to MCP server, and MCP server has many tools, right? So let's take very simple example to clear this particular MCP architecture. So suppose user asks what is 1, 2, 3, 4, 5 into 8, 9, 7, 6. So first AI agent receives the question. Don't you worry. It will be cleared 100% when we will implement and build MCP using n8n. Just listen this carefully. First, AI agent receives the question. Second, agent decides calculator tool is used as per this question asked by the user. Now, MCP client connects to MCP server. Now, MCP server exposes calculator tool. Now, calculator tool performs the calculation of this question and response come back through MCP. And finally, agent generates the final answer for the user, right? So this is the complete flow. Now here you can see some of the benefits of using MCP. First, standardization. One protocol for all AI to tool connections. No more custom integrations per agent required. Second, reusability. Tools built once, reused across multiple agents and applications seamlessly, right? That you can understand through this architecture. Agent to MCP client to MCP server. MCP server has many tools. Next, easier integrations, right? It provides plug and play approach. Connect new tools to MCP server, which is very easy. All agents can access, right? Any new tools are introduced, we have to connect through MCP server only, right? Shared tool ecosystems. Sure, a whole ecosystem, shared tools, multiple apps collaborate on the same resources, and it provides better scalability, scale agentic AI systems without multiplying integrations or connection complexity, right? Because we have to change here only, MCP server only, right? This is exactly why MCP has become such an important concept in modern agentic AI systems. Hope all of you are clear with this, right? Now let's implement and build MCP using n8n. Let's jump to n8n. Now that we have understood the concept of MCP, right? Let's finally implement MCP practically using n8n. Before building MCP, let's first understand the workflow that we already created earlier, that you can see here. Previously, our architecture was very simple. We had chat client, AI agent, OpenAI chat model, and tools directly connected to AI agent that you can see here. For example, calculator tool, Wikipedia tool, datetime tool that we have used earlier. So earlier, the flow was user, agent, direct tools, right? User, agent, direct tools, and final response. This means whenever the user asks a question, the AI agent received the question, the agent decided which tool should be used, the tool executed the task, the response returned to the agent, and the agent generated the final answer. This was the flow, right? And honestly, for small workflows, this setup works perfectly fine. But now imagine we are building large agentic AI systems where multiple agents need the same tools, multiple workflows use the same integrations, and different AI applications need to access the same tools. Then directly attaching tools again and again like this becomes difficult to manage, right? And this is exactly where MCP becomes useful. So now here you can see workflow with MCP that we are going to implement. Instead of directly connecting tools to the agent, MCP moves these tools under an MCP server. Then the AI agent accesses those tools using MCP client. So earlier, AI agent directly connected with tools. Now you can see the flow with MCP. AI agent, MCP client, MCP server, and tools. This is the most important thing to understand. These tools are no longer directly attached to the AI agent. Instead, they are exposed through the MCP server that you can see here. Now let's build this system from scratch. Now let's click over here, workflow and personal workflow. Let's give the name to this workflow, MCP demo. Now let's click over here. Let's search for AI agent. Let's press escape button. Done. Move here. So this agent acts as the controller of our workflow. Whenever the user asks a question, the AI agent receives it first and then it decides which tool should be used, what action should be performed, and how the final answer should be generated. So you can think of the AI agent as the brain of our entire workflow. Now let's click over here, chat model. And let's search for OpenAI chat model, right? I'm using OpenAI account and I'm using this model. You can use any, right? These many models are available, but I'm using GPT-5 mini. Done. Let's press escape key. So this is our OpenAI chat model. This model helps the agent understand the question, decide which tool should be used, and generate the final answer. Now first, let's connect some tools directly to the AI agent. Calculator tool, let's press escape. Date time tool, let's press escape. These parameters are okay for us. Add Wikipedia tool. Again, default parameters are okay for us. Done. So you can see at this stage, our architecture is still the old architecture, meaning AI agent and direct tools. And this is important because now we will transform this setup into MCP architecture. Before that, let's try to run this. Multiply 1, 2, 3, 4, 5 into 9, 8, 7, 6. Let's press enter. You can see now it has used this calculator tool and this is the answer, right? This is our old setup. Tools are directly connected, right? Now let's click this plus button and search for MCP server trigger. For now, these default settings are perfectly fine. Let's press escape key. Let's move here. So what is MCP server trigger? The MCP server trigger exposes tools through MCP protocol. Instead of directly attaching tools to the AI agent like this, we move these tools under the MCP server. You can think of the MCP server like a central provider of tools. It exposes those tools to external AI systems. Now let's move these tools to MCP server. Move this here. Let's connect to this. Let's delete this. And let's connect over here. Let's remove this. And let's move here. Done. So you can see now all these tools are exposed through the MCP server only. So now the architecture changes from AI agent, which is directly connected to tools. Now we have AI agent. Shortly we will add MCP client, then MCP server, and then tools. The core transformation happening in MCP. Now let's open MCP server trigger. And you can see paste URL and production URL. In this demo, we are going to use the production URL because I found some problem while using test URL. So let's copy this URL. Let's press escape key. Now let's click over here, tool, and let's search for MCP client tool. And here you can see endpoint. So we have to paste the copied production URL, right? Means MCP server as the endpoint. Done. This tells the MCP client connect to this MCP server. this particular MCP server using production URL. Now we have to choose this HTTP streamable, and this is deprecated, right? So let's use this. We not required any authentication, and at this time let's use all tools. So this HTTP streamable defines how communication happens between the MCP client and the MCP server, and we have chosen this no authentication, right? So what happens internally now? Now the AI agent no longer directly accesses the tools. Instead, you can see agent uses MCP client. MCP client connects to MCP server. MCP server exposes available tools. Agent uses those tools through MCP protocol. And this is the real power of MCP, because now multiple agents can reuse the same MCP server and its tools. Now let's test MCP workflow. Let's open chat. Let's perform multiply 1, 2, 3, 4, 5 into 9, 8, 7, 6. Let's press enter. Great. That I want to show you, right? Error in subnode MCP client. Please remember, we are using this production URL, right? So we have to publish this workflow. Then only we can use production URL. This is very important. That I want to show you. So let's press publish. Let's keep this version name as it is. And let's press publish. Escape key. Done. Right? Now again, let's try this. Multiply 1, 2, 3, 4, 5 into 9, 8, 7, 6. Let's press enter. And great. You can see now it's working fine. And this is the answer, right? Great. Ask one more question. What is the current date and time? Now you can see chat message received to AI agent, to MCP client, to MCP server, and this particular tool has been used. Great, right? So you can understand the internal flow. Chat trigger receives the question. AI agent processes the question. AI agent uses MCP client. MCP client connects to MCP server. MCP server exposes these tools. Agent selects the required tool. Tool executes the task. Response returns through MCP client, and agent generates the final answer, right? And this is the MCP flow. Now again, let's ask what is 1, 2, 3, 4, 5, 6 into 9, 8, 7, 6. Great. Here you can see now the agent automatically selects the calculator tool through the MCP server and generates the answer that you can see here. So you can also test other tools like Wikipedia tool that we have used, date time tool that also we have used, and any other MCP tools. Now the one main point. Let's click here on MCP client, and here you can see we have already selected this all tools, right? Suppose you do not want the agent to access all tools. So here we can select this selected, right? And here as per your requirement, you can provide Wikipedia or date time or calculator, right? Only selected tools. Now agent can only use those selected tools only. Hope all of you are clear with this, right? You can try this. So as you can see earlier, tools were directly attached to the AI agent that you can see. Now with MCP, tools are exposed through MCP servers and accessed using MCP clients. This provides reusability, standardization, easier integrations, shared tool ecosystems, and better scalability. Hope all of you are clear with this, right? How MCP works. So you can see this is exactly why MCP is becoming such an important concept in modern agentic AI systems. Hope all of you are clear with this, right? Let's move on.